Good afternoon, students. Today's topic is grade 10 chemistry, acids, bases, and salts. We are not completely discussing the whole topic. We will limit ourselves to the definition and classification in this part of the lecture. First and foremost thing, what are the theories which will explain about acids or bases? So you should have some idea about that this particular chemist has given this theory like that. So what are those theories? First one is given by Arrhenius. Hence we call this theory as Arrhenius theory of acids and bases. In grade 10 we have Arrhenius theory. If you move towards grade 11, we have Lewis acid base theory and Bronsted-Lowry acid base theory. So at present we are not going to discuss Lewis theory as well as Bronsted-Lowry theory. In grade 10 we are limiting ourselves to Arrhenius theory of acids and the bases. So let us continue with this. So what is this Arrhenius theory? Let us take a substance A, add water to this. I have taken a substance A, add water to that, and if it gives us H plus ions, then this substance A, according to Arrhenius, is called acid. Now let us take a substance B, once again add water, that means in aqueous solution. If it gives OH minus ions, that is hydroxyl ions, then this B, according to Arrhenius, is called a base. So hope you have understood this. One more point to know, when there is water and H plus, that is protons, this will give you H3O plus, which is known as hydronium ion. So here it is hydroxyl ions. So once again I will give the definition. Any substance in the presence of water gives hydronium ions, that substance is called Arrhenius acid. If any substance in aqueous solution gives OH minus ions, that is hydroxyl ions, that substance is known as Arrhenius base. Shall we see the examples here? Now I will take HCl in presence of water. Okay, so HCl in presence of water splits to H plus and Cl minus, and once again you can also tell that H2O plus H plus gives hydronium ion, or you can also say that it is H plus ions. Because this substance has released H plus ions, this is considered to be an acid. Some more examples also you can take. H2SO4 in presence of water will give you 2H plus and SO4 2 minus. I have given in a single step. Generally it will split into HSO4 then into SO4 2 minus, but again due to the release of H plus ions, you can say H2SO4 is an acid. This is hydrochloric acid, this is sulfuric acid. You can take a number of examples, but I hope you have understood with these two examples. If you still want, you can take HNO3, add water, you will get H plus and NO3 minus. So nitrate ion, and again you have H plus ions liberated, these two together forms hydronium, hence HNO3 is an acid. Which type of acid? Arrhenius acid, and you call it as nitric acid. First part is completed. Let us see about the base. According to Arrhenius, Base is a substance. B in the presence of water gives hydroxyl ions. Now let us take examples. NaOH, CaOH twice, and AlOH thrice. So in these three conditions, what happens? In presence of water, what is liberated here? So I can write it as Na plus and OH minus. Here I can write Ca2 plus and 2 OH minus ions. Here I can write Al3 plus and 3 OH minus ions. Please don't see whether it is completely soluble or partially soluble, like aluminium, whether it is partially or completely soluble. I am just giving you an information that here OH minus ions, that is hydroxyl ions, are liberated. In this case, and this case, all the three cases, OH minus ions are liberated. Hence, we can say that these three substances can be called as bases. Later we will see water soluble base is known as alkali. So one more statement is given. After this, we have to take each one and try to check the complete solubility of that in water. Example, NaOH you take. NaOH is clearly soluble in water. Hence you can say that NaOH is a water soluble base. You can call it as alkali. Hope you are able to follow this. If at all it is not soluble, like you can take D block elements and all, they can be called as only bases, but they cannot be called as alkalis. This and all is not discussed here. What we are discussing is, we are discussing the definition of a base. In the presence of water, the base gives hydroxyl ions. So hope you have understood what is meant by Arrhenius acid and Arrhenius base. Next, after this definition, you have what are the types or what classification you will follow in this. Let us see. Second one is classification. See, classification means, let us take acids. How to classify them? On various methods. First one, that is nothing but based on the source, you can classify acids as organic acids, and second one is mineral acids, and B. So depending on the number of, see, we will see what is, if at all you take an acid, depending upon the number of H plus, or you can also say depending upon the basicity of acid. We will discuss that later. What is the second one? Depending on the basicity of the acid, we classify them into monobasic acid, dibasic acid, tribasic, tetrabasic, and so on. So very simple. If you are taking the classification of acids first, based on the source, we can classify them as organic acids which are synthesized like in the humans, HCl, or in plants, etc. Mineral acids you can get it from the minerals, or you can prepare them in the lab. We will see with the examples. Next one is basicity. Depending upon the H plus ions which are reacting with the OH minus or basicity, we classify them like this. So one by one we will see that. First one, organic acids. Organic, what does this organic indicate? Organic chemistry deals with the study of carbon compounds, that we know. So which is present in plants or animals in general. So if at all I'll take HCOOH, this is called as formic acid. Formica, red ants. So this acid is present in red ants, organic acid. Second one is CH3COOH, nothing but acetic acid, vinegar. It is also organic. And then we can also consider an important thing, that is nothing but HCl, which is present in the gastric juice of human beings. One important note, HCl comes under both organic as well as mineral acids, because you can prepare HCl in the laboratory also. Second one, I am having mineral acids. The second one is mineral acids. So you can take like HCl, you can synthesize in the laboratory, then HNO3, H2SO4. So all these are the acids which can be prepared in the laboratory. They are known as mineral acids. In this, one exception is there, that is HCl. So you know, right, H2 plus Cl2 gives us 2HCl. Using this we can get a HCl. So hope you have understood the first type of classification, that is how acids are classified depending upon the source, whether they are organic or they are mineral acids. So I will erase the first part. Second one, how do you know whether it is a monobasic, dibasic, tribasic, etc.? Take the example. I am having HCl. You know, if you take HCl, it will split into H plus and Cl minus 1. Is it right? So how many protons or H plus are liberated? You are liberating one proton. Fine. So how many, see, this is an acid. To neutralize this, how many base you need to add? I will just add one NaOH molecule, so that one H plus requires one OH minus to form nothing but a salt plus water, NaCl. I think you are able to understand. You have an acid. This acid has liberated how many protons? Only one proton. Because of that, you need how many hydroxyl ions to neutralize this? You require again one. So we can say that the basicity of this acid is equal to 1 now. So let me write here monobasic, example HCl, HNO3 in this case. The reason is simple. They have one H plus ions, hence they combine with only one OH minus, that is basic hydroxyl ion. Hence you call them as monobasic. Okay, this also you can rub and write like this. These acids will combine with one OH minus, hence you call them as monobasic acids. Second one, let us take dibasic. Dibasic H2SO4 you take. Now H2SO4 contains 2 H plus ions. Therefore, to neutralize this, we have to add, let us add here itself, we have to add 2 OH minus, then only it will convert into 2 water molecules. To write that complete equation, we can take like this, plus let us take 2 NaOH gives us Na2SO4 plus 2 water molecules. In this, very easily you can identify, you are having 2 H plus, hence you have added 2 OH minus. So I can write here H2SO4. One more example, H2CO3. They contain 2 H plus ions. Hence, you want to add 2 basic radicals, or in other words, 2 basic hydroxyl ions. So therefore, you call this as dibasic acid. If you want, you can take H2CO3 plus 2NaOH gives you Na2CO3 plus 2H2O. Again, you can identify 2OH minus, hence they are dibasic acids. Hope you have followed the second one. Now the third one. So let us take phosphoric acid, H3PO4, phosphoric acid. So in this condition, easily you can identify that it gives you 3 H plus ions, hence you have to add 3 OH minus to this. Directly we can say that because you want to add a 3 OH minus, that is H3PO4 is considered to be tribasic acid. So hope you have understood this. So depending upon the number of H plus, you will add a number of OH minus, that is nothing but it gives us the basicity of the acid. Next step. Because you know about the classification of acids, let us see the classification of bases also here. So how we can classify them now? First one, monoacidic base, that is NaOH, you can take KOH, etc. Nothing but which contains 1 OH minus ions. Now if you want to add an acid to this, I can add 1 H plus. So 1 OH minus will combine with 1 H plus. So therefore what will be your product here? NaCl plus H2O. So we can define like this. In this particular base you have 1 OH minus. Therefore, to neutralize this, you want to add an acid which contains 1 H plus. Hence, what do you call this? Monoacidic base. I think you have understood this with the example. In this example, you are having, this is a base first of all. Why it is a base? Because you have OH minus. To neutralize this, you want to add an acid. In the acid, how many H plus are there? 1. Hence, what do you call this? Monoacidic base. Same thing will happen here. How many OH minus? 1 OH minus. Therefore, we need to add 1 H plus for neutralization. So, you will get KCl plus H2. So, this is the first classification for the base. Second one. Diacidic base. So let us take the base with a 2 OH minus. Here you can see OH minus 1, 2 are there. Then any other things you can take. CuOH twice also you can take. Okay. So in these two examples, we can say that first of all they are base because they have OH minus, OH minus. And second thing is why they are diacidic, because to this you need to add definitely 2H plus. 2H plus. Then only neutralization takes place. So I am not giving the example H2SO4 or something, but outer line if you see you can understand very clearly. In this you have 2 hydroxyl ions, therefore to neutralize you want to add 2H plus, hence it is called as diacidic base. Third one, you can also take triacidic base. So what is triacidic base? 3 OH minus should be there. Example, you can take AlOH3. Here how many OH minus? 3 OH minus. Hence to neutralize you have to add 3H plus. Because you are adding 3H plus, it is called triacetic base. So hope you have understood the classification depending upon the number of OH minus in the case of a base. Next, one more important classification we should know before we start with the salt, that is strong acid, weak acid. Let us take like this. Similarly, we can explain about the base later. What is a strong acid or what is a weak acid? You know, according to the theory, any acid which completely releases H plus ions, here very important, any acid which completely releases H plus ions is known as a strong acid. What is a weak acid? Any acid which partially release H plus ions is called weak acid. And one more hint, all the organic acids are weak. Organic acids are weak. So hope with this information we can take some examples and we can solve this. Number 1, HCl in water completely dissociates to H plus and Cl minus. See, how many hydrogens are there? 1 hydrogen. How many protons are there? 1. It is completely dissociated. Completely, you can write completely dissociated or released. Hence HCl is a strong acid. Second one, H2SO4. It is also dissociated completely. Okay. 2 hydrogens and 2 protons, completely dissociated. Hence it is also a strong acid. Take HNO3, H plus and NO3 minus. 1 hydrogen, 1 proton, completely dissociated. Hence you call it as a strong acid. So these are the 3 examples of strong acid. Coming to the organic acids, you know, formic acid, acetic acid, you can take this. Okay. So if you take organic acids, now what will happen? Even if you split this, right, in presence of water, it will split into HCOO minus and H plus. You know what is meant by HCOOH? It is called formic acid, and this ion is called formate ion. Now, how many hydrogens are there? 2 hydrogens. But how many protons are there? Only 1 proton. It is not completely dissociated, it is partially dissociated. Hence, we can call formic acid as a weak acid. Come to the second example. It is acetic acid. Addition of water gives you CH3COO minus and H plus. Once again you count totally 4 hydrogens, but here only 1 proton. We can say that it is again partially dissociated, or it is partially releasing H plus. The name of the acid, acetic acid, hence the ions can be named as acetate ions. So hope you have understood. We took 2 examples in which upon addition of water, it is not completely dissociated into H plus ions or H3O plus ions. Hence we call these 2 as weak acids. So hope you have understood. Next, so keeping this in mind only, we will talk about the salts at the end. So hope you have understood this. Next, strong base or bases. Next comes a weak base. Now, what is a strong base? Once again, with the definition of acid, we know the base which completely dissociate into OH minus hydroxyl ions. But what is a weak base? The base which partially dissociates into OH minus. So here it is partially dissociating, here it is completely dissociating. Simple examples we will take. NaOH, aqueous medium, splits into Na plus and OH minus. Here you have OH and here one OH minus. Same way, KOH, water gives K plus and OH minus. So likewise, what we can understand here is there is a complete dissociation in this base into hydroxyl ions, hence you call them as a strong base. Some more examples are there, but I think this is enough. Partial dissociation can be seen in ammonium hydroxide. This is forward reaction. So NH4 plus and OH minus. See, there is a dissociation of OH into OH minus, so we can say it's a base. But after some time, what happens? The backward reaction takes place, in which ammonium ion again combines with the hydroxyl ion, and you will get ammonium hydroxide. Due to this partially dissociation, we can say that NH4OH is called a weak base. Okay, so hope you have understood about acid base definitions and classification. Now the last part, that is, depending on these two, you can easily write the salts. So what is meant by neutralization reaction? Right from the lower classes, we have been studied that acid plus base gives salt plus water. A very important reaction, that is acid plus base gives salt plus water. So this is the neutralization reaction, we all know. Now how to define salt formation? The compound which is formed by the addition of an acid and base is known as a salt, that we can say. Okay. So now, depending on this, I'll give classification also. What is that? First type, neutral salt. What is meant by a neutral salt? A neutral salt has combination of strong acid plus strong base, otherwise weak acid plus weak base. Hope you are able to understand this concept. I'll write the examples later, but first try to understand neutral. Why it is neutral? Because both acid and base are strong, it is neutral. Both acid and base are weak, it is neutral. Let us take for this example strong acid HCl, strong base NaOH. Now Na is plus, Cl is minus. So the salt is NaCl. So it is known as a neutral salt. It is known as a neutral salt. It does not have acidic nature or basic nature. The other product is water as usual. Hope you have understood this. Now, second example, weak acid. Let us take formic acid as an example. Just now we have discussed in the previous slide that is water, strong acids, weak acids, like that. And from that weak acid I took this. Now the weak base, ammonium hydroxide, again NH4 plus, and here we have H plus and HCOO minus. So we got HCOO minus NH4 and water. So this is called as ammonium formate. This is called as ammonium formate. So formic acid plus ammonium hydroxide gives ammonium formate. This is also a neutral salt. Why it is neutral? Because acid is weak and the base is also weak. So hope you have understood the first type of salt. I'll erase this. Second one. So many definitions are there, but this definition will give you an idea depending upon the weak acid or strong acid in that aspect we have taken. Okay, fine. Second one, acidic salt. See, acidic salt, even if there is one H plus extra also, you call it as acidic salt. Or from this definition what I can take is, acidic means acid will be strong. Acidic salt, in that acid will be strong and base will be weak. So example, strong acid HCl plus weak base ammonium hydroxide, you take plus and minus. So what you will get? You will get ammonium chloride. So ammonium chloride comes under acidic salt depending upon the strength of the acid and base. Now the last one, that is basic salt. See, with all these examples you yourself can guess. Acidic salt means which is strong, acid is strong. Now basic salt means which will be strong here, base will be strong. So base will be strong and acid will be weak. You know the examples, formic acid. Formic acid is a weak acid but strong base, you can take NaOH. This is plus HCOO minus. So get your ions HCOO Na. We know that HCOOH is formic acid, therefore this is sodium formate plus water. So what happened here? You are having weak acid but the base is a strong base, hence this particular salt now is a basic salt. But in the previous case, this is strong acid, this is weak base, hence here we can say that it is an acidic salt. So in this lecture I have just given you introduction about only one theory, that is Arrhenius theory of acids and bases. Depending upon that knowledge we have discussed about the salt, its definition and about the classification into 3 types. Hope you have understood this. Thank you so much.